This bridge SIG presentation is on the OpenBridge products and talking about the plans production process, some of the tools related to that process, and just kind of how it all works together. And so hopefully this will be very informative for you. We're going to review model types. I've been working with a lot of agencies now and consultants both that if you ask folks, are you using design models or drawing models or sheet models, if they kind of give you a blank stare or don't answer, or these days it's all virtual, so if they don't answer, you're probably using design models. You probably haven't taken that deep dive on into drawing and sheet models and dynamic views and everything involved there. So we're going to try and lay the framework for what are all these things and how do they work. Talk about detailing symbol styles and kind of how they dovetail into all of this, along with display styles. And then we'll take a look at some of the native tools, or some of the tools that we add on the OpenBridge side that are specific to creating some drawings. And then we'll look at some of the more generic MicroStation tools that are out there as well. And talk maybe pros and cons on both and when you might use each. Now in here you're going to see a few references. You'll actually see more of them. Next month's SIG will be how to set all this stuff up. Okay, so today we're focusing more on how can we use those tools and what are they. And you really need that understanding before you can probably figure out how to set them all up. But I used a lot this drawing composition PDF from our MicroStation folks. And so I've put little green notes on some of the pages that have sheet number references back to this training guide. So if you go to learnbentley.com, you tell it you want to learn more about MicroStation. Once you get on the next page, you can say, okay, I want all the advanced topics. Of course, I have a lot of advanced topics, but one of them is this one called Design, Drawing, and Sheet Composition for CAD managers. And this has been a really good reference. Not only can you download the document and data set, but they have videos to go with each of the exercises as well. So again, if you see any pages XXXX in the corner of any of my slides here, it's referring back to this manual right here. And I have it open and available here if we need to reference it as well. We can jump in there and maybe answer any questions I don't know off the top of my head later. So, model types and dynamic views. Models have been around for a long time, but for the most part, like I said, we've mainly used design models to do everything we've been doing. And these models, I mean, this is pre-MicroStation V8i and all that, but of course I'm dating myself here, but back in the day, each DGN, there weren't models. I mean, there was one model. It was either the DGN itself was 2D or 3D, it was imperial or metric, so on and so forth. Now within one DGN file, you can have as many models as you want. Each one can be 2D or 3D. Each one could be imperial or metric. They each have their own views, their own MicroStation elements, their own view attributes. There's a little bit shared amongst those, like level names and things like that are available in all of them, but generally they're almost like a self-contained little DGN file from back in the day. And then a while back we added different types of models, and like I said, there's three types: design models, drawing, and sheet. And again, if you're not familiar with these, you've always been using a design model. You've probably been drawing everything to actual size and then scaling it up or down to a sheet and generating your drawings and sheets that way. So think of this as a completely different way of doing the process here, but starting with a 3D model from our OpenBridge model. And the primary tool we'll be using kind of behind the scenes. There's no one button that says, I want to use the dynamic view tool. It's just something that's kind of baked into a lot of the other tools, but in its simplest form basically allows us to slice and dice these MicroStation solids and represent them in a 2D way. So, and it gives us some links between the 3D model and the 2D drawing, and allows you to go back and forth. And there are some special call out tools here that essentially are doing dynamic views for you. So there's a section call out, plan, elevation, and detail, and so forth. Again, these dynamic views is just kind of a general name. Like I said, it's not a specific tool or anything that encompasses a lot of related technologies. And instead of having a snapshot of the way something looked in time, you can use dynamic views. And what that gets us is if the model changes, if that 3D model of our bridge changes, or a roadway or a building, whatever you have, then as long as you are using dynamic views, then the 2D drawings update instantaneously, the sheets update as well. So all of those things are, like I said, a live dynamic slice through the model. And there's some good discussion on pages 7 to 12 of that PDF that talk about all of this. And so I've pulled a little bit of that out here, but it's a process of creating views. It can seem daunting initially, but hopefully we'll kind of boil all that down in this session here and help you understand all of this. So here's a workflow. This I just stole, I'll be honest, stole right out of the that training guide or that PDF. But it does a really good job of explaining why we have all of these things and what they are and when they're used. So the master model, think of that as that's your 3D design model where you have your bridge, your roadway, your building, whatever it is you've modeled. And now somebody wants to see some drawings and sheets and so forth of that model. All right. So we have a create drawing tool, and this looks very similar whether you use, let's say, the section call out tool or the elevation call out or some of the different ones. This particular one is from the section call out, and that's the one I'm going to probably use the most today and refer to the most, but just so you know, there are others. In this tool right here, when you call it up, initially you have to give it a name up here, okay? And what this name is doing, this part of the dialog right here, this part of the window here, is basically just creating a save view. And you're like, well, gee, save views have been around for a long time. Those have been around, geez, actually since the VAX days, IGDS days, way before there was a MicroStation, we had save views. But that's what it's going to do is you're going to strike a line out there and say, okay, I want to create a slice through my model right here. And if you only do this, if these next two are turned off, if you don't do a drawing model, you don't do a sheet model, it just creates a save view and it stops. And you're like, well, why would I use that? Well, a save view can be used as a reference. Okay, if you picture the references dialog, when you hit attach, it gives you a bunch of options in the middle of the dialog there. And one of the options is, just attach a save view. So if you tell it to go ahead and create the drawing model, what it does is it creates a drawing model using some seed file that's configured ahead of time, and that's what we get into next session. But this seed model would have, you could have a seed drawing model here, which is just a blank 2D model. And then you tell it, okay, here's the annotation scale we're going to use in there. And for visible edges, I want this to be dynamic. Again, as long as this is set to dynamic, then any changes to this model get reflected in this drawing model and they get reflected in the sheet model because they're just references at this point. They're just a live reference back to this guy right here. So keep that in mind. And then lastly, we have sheet models. So you can create a drawing model without a sheet model. You can go the other way around. You can go straight from the 3D model straight to the sheet if for some reason you don't need a drawing model for what you're doing. Now when it comes to the sheet model part, you can have multiple sheet models set up and ready to go. There's always going to be a default one, but you could pick a different seed model and then go ahead and create this. Now the difference between these, let me back up just slightly. In the drawing model here, this is always scaled 1:1. This is just a live reference of the master model here via a save view. And this is where you're going to want to place all of your annotations and callouts specific to that section, whatever it is. Whether it's an elevation view, a section view, plan view, whatever you have. And any annotations or callouts specific to that guy right there probably go in this file or in this model. And then the sheet model, this is probably going to be at print scale. So the sheet itself will be a B size or a C size or an A0 or A1 or A3, whatever your sheet size is. It'll be actual size, and then we'll reference this or scale this up or down at whatever scale we want to fit within the sheet. So it's just, you could have one drawing model attached here. You might have 5 to 10 different drawing models attached to one sheet, depending on how many different little details you have on that particular sheet. You can place annotations and callouts in here, but those are going to be things maybe specific to the sheet. Let's say filling out title blocks and those sorts of things, or just maybe general notes that cover everything that's on that particular sheet. Then you would have annotations and callouts on that particular sheet model, and then from there, that's where you're going to do your printing and publishing. So next up here, again, from that, your master model, you're going to have a lot of save views, which will in turn create each kind of a one-to-one. These are going to be drawing models here, but it doesn't have to be from here one-to-one on into creating a sheet model. All 4 of these drawing models maybe just go on a single sheet. Okay, so there's going to be a lot of that going on. And it's entirely up to you as you're working through this process. And you can see it here where it says file name, and it's grayed out because this little check mark is not enabled. You can put these drawing and sheet models either by default in the active file, or you can use this folder icon here to go out and select some other file and say, hey, put my drawing or sheet models in this file. Or there's a button here to just go ahead and create a new file using some seed model that you have here. So a lot of different options. No right or wrong answers, but entirely up to you on how you want to break out the drawings and sheets relative to the DGN file itself. And I'm probably going to go through this stuff a little too much, but I'd rather cover it too much than not enough. So again, the design model, that's your 3D BIM model there. The drawing model, always 2D. You don't really have an option there. Those are always 2D models. That's a live slice from the design model, and they're always one-to-one size-wise, so you can use your measure command and dimension command as needed in this drawing model. And then the sheet model can be 2D or 3D. You can actually reference, you can have a 3D sheet model or reference 3D stuff to that model. Typically, most of it will probably be 2D though. Okay, so again, there's our drawing model. Here's what it would, or I'm sorry, design model up here at the top. This is our drawing model, what it would look like there, and then this is that same up here on the sheet model. So where do we find all these different models that get created? So within OpenBridge Modeler anyway, it's right here, right below the Home tab, this little blue icon right here. Select that, and that will show you all of your different models. And you'll notice I have 3 models in here, and each has a different little icon or type out here in the front. My default model is 3D. That's what this icon's trying to tell me. These others are 2D models. But then out here to the left, it's showing me these icons. So this icon right here is my design model. The one with the corner clipped off here is my drawing model, and then the one with the sheet border looks to be my sheet model. And then as far as annotation goes, again, drawing annotation will go in the drawing model. So all this annotation we see here that I've pointed to with these arrows, those are in the drawing model itself and then just referenced on to the sheet. The sheet annotation, again, is things like title blocks, general notes, things that maybe aren't specific to a given detail. So if we look at this another way, okay, so here's my OBM 3D model that we can use for our clearance checking or conflict detection or abutment grading and generating all of our drawings, 4D, 5D simulation, on, a lot of reasons to do these 3D models. From that, you can create references, and I've been doing more of this myself. Is I'll go in and just create an empty file, an empty 3D file, and then reference the bridge to it, and then do some kind of a clip and say, okay, I'm focusing on this abutment or this pier or maybe just the deck, some part of the overall design, and do your work there. In this particular case, all the reinforcing was done in this referenced model. So reference the bridge to an empty DGN and added all the reinforcing at that point. And then from that, start using like section callout tool and generate drawing models. And they're from this detail right here, you're probably going to have a lot of different drawing models to show various aspects of this. You're going to show it in a plan view. You're going to see it in an elevation view. You might want to see the footing only in a plan view. You may do separate things for these walls if they're different somehow. So each of those would have their own drawing models. And then from that, you could go about creating your sheets. Now, it is possible, since I can reference this stuff back to my drawing, I could generate the drawings from here as well. Again, no right or wrong answer there. But again, in summary, you're going to have a lot of design models that have all your bridge itself is a design model. Any reinforcing you do, if you break those out to separate files, those will be design models. And then the drawing models will be generated from those using the dynamic view tools we talked about earlier. And then the sheet models will be references of those. As part of this process, when we go to do things like place a section callout, place a plan callout, do an elevation callout, there are some predefined detailing symbol styles out there. And you have to have those out there. You can't even, if you try to even, I think, start MicroStation without them, it warns you. So we do deliver some by default. They're in our program files folder. Okay, so be a little careful there. But they are in program files, Bentley, OpenBridge, so on and so forth. Because almost everything else workspace related is under program data somewhere, or wherever you have your workspace resides today. So for agencies that I've been working on and setting up some of this stuff for them, I'll just take this guy and make a copy of it and put it in the workspace in a similar folder at the workspace level, instead of using the one that generically comes with the software. But these detailing symbol styles are all customizable. There's a lot of other stuff in this particular file. This drawing seed file has probably almost too many eggs in one basket, let's say, but it does have a lot of other stuff beyond the detailing symbols in there. Because each of these, like at each end of these detailing symbols, these are all cells that you could go in and modify and override. And there is a little detailing symbol style dialog that you can open up on how to go about configuring all of these. And again, there's some really good discussion in that PDF on these pages down here in the bottom. And then display styles. And it was interesting, this actually kind of came up this morning. I was talking to somebody, and we took kind of a deep dive into display styles and what those are about. And essentially, if you're doing anything in 3D, you're using these all the time. Because if you take a look at your presentation, you go to your view attributes here at the top of any view window, you can tell it, wireframe or hidden line or illustration mode or smooth or whatever. Those are all display styles. Okay, that's what these guys are over here. These are all in a DGN library. They're in that same drawing seed DGN library by default, but you can move them somewhere else or put them somewhere else or create your own. But basically each view has its own display style, and those control how things look to you in that particular view. And you could have things as wireframe in one view, and maybe they're filled in another, and they're and there's really no limits to what you can do here. Now I just kind of have this in passing, this word display rules here, but this is really kind of key to a lot of this too. For any of you that have done a lot of plotting, you may have used and may still use pin tables to force things to look a certain way on the final sheet or in the PDF or something like that versus how you drew it. So you can kind of do some level overrides or apply some symbology kind of on the fly as things are drawn. Think of display rules as doing that for a view, for your drawing. Because up here you can define with any display style, you can have display rules associated with them. ORD comes with some initially. So they have something that says like concrete cut shaded or concrete forward, or they have some that say like highlight, here they are down here, highlight asphalt pavement, highlight concrete pavement, so on and so forth. These display rules, you can go in and drill down into specific levels or colors, or you can pull element attributes, or you can say, hey, if an element is in a file that has a certain logical name, make it look this way, make it look transparent, make it look gray, or take contours and kind of screen them and do things like that. So keep these guys in mind. If you're having trouble getting your display to look the way you want, using all the everything here other than display rules, if those don't do it by itself, this is probably going to make it look just about any way you want. So I put together a short little video here to kind of try and describe all of this. So what I've done here, and I want to pause this for a second, is from a top view, I've already done a section cut here. Okay, I use the section callout tool, and we'll see that happen later. But I've used the section callout tool and just did a slice down through my deck, my beams, my barriers, my pier, and so on and so forth. So it's right here. Okay, here's what that same thing looks like. So here's what that pier looks like in a front view, let's say, or a side view if you want to call it that. And then here's my drawing model that was created from this line right here. Okay, so I'm looking at two different models here at the same time. I'm looking at one in a top view here as a wireframe, but I see that there are a lot of other options here looking at this particular view. Same with this view over here, this front view. I can come in here and I can select some other display style. So I'll go in and pick one of the others, click out here. So I said highlight superstructure. Boom, it shows me that. And then I have it set to kind of gray or screen everything else out and make it look really transparent. Or highlight substructure. So on and so forth. There's really not any limitations on what we can't do here. So go back to transparent. I can make this one wireframe as well. On and on. And then from that, we can go in and control these cuts as well, are also controlled by those display styles. So I'm going to pause this real quick. So I've selected this little line right here. Now associated with that line really is a 3D cube. But this line right here is what is referred to as the cut line. Okay, so keep that word in your head there. This is the cut line. You'll notice an arrow here. This is showing me what direction am I looking here, or we can see it down in this view as well. So I'm looking from left to right, let's say. So picture yourself standing here looking towards this little blue push pin over here to the side. So this is your forward clipping plane. So anything inside this rectangle right here, between this purple line and this white line, this is the forward plane. This is your cut line. This is your forward area. Anything from this line back to this one, that's your back area. Okay. And then there's a fourth term, we'll see it here in a moment, called outside. So if it's not at the cut line, if it's not forward, it's not back, then it's outside of that area. So why are you telling me all that? Again, remember, this guy over here is a reference. Okay, and you can move these lines at any time. If it doesn't end up where you want, that's fine. But just note, where this line is. It's right at the center of the cap. Okay, I was careful when I created it, and I did it on purpose. That's right at the center of the cap. So I'm going to come in here to my reference for this guy right here, for this view 3. I double-clicked here under presentation where it says from clip, and I'm going to turn off forward. Now, what it did is when I turned off forward, the pile went away out of this view on the right, which we couldn't really see with that dialog up. But then I also lost the bearings and pedestals over here on the top of the cap. Now, why is that? Well, if I go back and I select this line, we'll notice that it doesn't intersect any of those bearings. It does not intersect the pile. So with, when I went to that reference window a moment ago and I said, show me only the cut, that's what it's showing me. Is it's showing me exactly where the cut occurred, what's going on, and nothing else. So if I go back to that and I say, let's go ahead and turn forward back on, and we click OK, then we'll see those changes occur here. So now I can see the pedestals. I can see the pile because they were within the limits of that forward view. So CC1 is the name of the display style I'm using at the cut here. So I'm going to go in and modify it. Let's go in and modify the CC2 or CC1. I made a copy of it, called it CC2. I'm going to go in and make some changes here and say, you know what, instead of seeing these as black elements that are weight 2, let's maybe make them white or some other color there. And then what I need to do is go back to references one more time and say, hey, let's use this CC2 display style here. So it drops down, shows me a list. I say apply, and now I can see the cut elements are a different symbology than the forward elements. And I can always go into here and select some other color and really make these things pop out or look any way I want. And then from that, actually what I could have done, I'm going to go back to references here and reselect that. But if I had, what I've since learned since I created the video, is I can zoom in and out just in this view, and that would force it to update this as well. So a lot of good stuff there. You can control so much of this and get it the way you want to look pretty much by using the tools that we have here, these overrides and edge settings, because the gentleman I was talking to this morning was trying to use a lot of level overrides to force things to look a certain way without realizing that these display rules are here and what those are potentially capable of. So again, I think you can do a lot of it here, but the display, and if you don't do any of these overrides, then the color of the elements here and the color of the style and the weight is whatever was used to create that element in the 3D model. But by default, we have some overrides that get applied there. All right, let's take a look at some of these tools that we have on the OpenBridge side. So if you go to the Analysis and Reporting tab in OpenBridge Modeler, you'll see this is a subset of some of the tools that we have there now. Again, these are some specialized tools that make it pretty easy to do some very specific things. Very efficient workflow for generating these drawings. Again, they're all dynamically updated, and the model annotation stuff, we're using the same tools from the Open Roads folks to do a lot of that. Plus, these name boundary tools and some of that we see here are theirs. Now, dynamic view by station, that is an OpenBridge specific one. So you go out, you start this tool. I typically lock in a skew angle of 0 or whatever the angle is that I want to use there. But this is going to make it very easy to go in and create a perpendicular cut. And in this case, if I do it out here in space somewhere, it's basically going to generate that's going to be my typical section of my deck potentially. So I've set a skew angle of 0 and a depth of 0. So it's going to be an exact slice right there. Opens up the Create Drawing window. I give it a name. Remember, the top part here is the name of the save view. If I optionally go ahead and let it do the drawing and sheet model, it'll do those. It'll just use that saved model name for both of those. And then here's what I end up with. Because I had some references still turned on, I got some extra elements out here. I had the ground element, and I've got some stuff down here at elevation 0. But very easy to go in. Just go to the selection tool, hover over this, right click, tell it you want to move the reference, and then drag it down there to the sheet. But this is a live slice through the 3D model. So if changes are made to the model, this is going to be reflected in it automatically as well. So let's go back and maybe do one more slice here down through one of the piers. So I'm going to come in here, select the alignment again, and then this time I'll just snap to one of the support lines out here and cut a slice at the center line of the cap. So we'll give a data point. I can see I'm looking up station. That's really what I want. I'll go ahead and give this a name. Again, if you want, create a drawing model and or sheet model. You don't have to do either, much less both. So there's our drawing model with the pier in it. Again, there's my ground line. All things I can turn on or off once I have this generated. Some of the other drawing generation tools. So these have been around since the very beginning of the product. So we have some, and these tools will do what we call predetermined cuts. You don't really have a lot of control over this, but you do have a little bit with the settings that we'll talk about here in a moment. But these are user-defined setting. You do get to do some user-defined settings for how that cut occurs, and especially for if you have your own dimension styles that you want to use, because with our tools, with this create drawing tool right here, this is for substructure elements, and then this is for your typical section type of a look. We will do some automated dimensioning there as well. So within the settings, like I said, you can turn on auto dimensioning. That's typically on by default. So is clipping of the elements. So in the auto dimension, you can tell us what dimension style to use, and we now have pick lists here for these. So if we see it in one of your DGN libraries, it's available to use, and we'll do that. Here in the upper right, this is for any substructure views that get created, or anytime you use the substructure tool, we always generate an elevation view. Optionally, you can create a top view, right view, bottom view. So top, in my thinking, is the plan of the cap. Bottom is your plan of footing, and then right and left are just a view from the right or left side, or a section view of that pier or abutment. And then with the clip tools, this is for clipping of any columns or piles. So if you only want to show maybe the top 2 or 3 feet and the bottom 2 or 3 feet, this tool here, by using clip will do that for you. So let's go ahead and take a look at a quick video on this. So this is, again, our create drawing tool. I selected this one right here. I click on the pier and accept it. It goes straight to the create drawing window. Go ahead and name. Again, this is our save view. That will also be the name of the drawing model and or the sheet model. So I'm going to give it a scale here, and you'll notice for this annotation scale in the drawing model and the detail scale in the sheet model, usually want those to be the same. So it went off, it created the drawing model, created the sheet model, it referenced the drawing to the sheet, went back to the drawing model, added all the dimensions, and then went ahead and threw us back in the sheet model. So it was going back and forth several times there, but this is, again, is all live stuff. All these dimensions by default are associative dimensions. Again, so if the model changes, the drawing model changes, the sheet model changes, and the annotation would change as well. Superstructure, same sort of thing. So I'll go to the superstructure tool, tell it I want to create a model or a drawing of that, pick the alignment, pick the location. Now if you're careful, you'll see a little blue arrow here that's showing you what direction it's going to be looking. I wish our dynamic view by station had that, and maybe we'll get that added one of these days. But very nice to know, are we looking up station or down station, especially when your bridge is on a curve. That could have a potentially huge effect as well, or if it's not, in this case like this one, it's also not symmetrical. So there's our, and I told it drawing model only, and so that's what it's done here, is left us in that drawing model. The create substructure drawing tool will work with abutments as well. So you can always go in and select a pier, give it a name here, or I'm sorry, select your abutment, give it a name, create a drawing and or sheet model of that. And similar to what we saw with the pier a moment ago, if I zoom out here a little bit, we'll see the plan of the cap. We had an elevation view there, a section view, and a plan of the footing, which was in this case basically just the pile. Okay. Microstation drawing tools. So over and above what we've looked at so far, again, OpenBridge Modeler is built on MicroStation, so we have all of their tools available to us as well. And for the most part, you can probably do everything you really need with this section callout tool. It's not really quite this big, but anyway, that's how it looks on the slide here. But it can be used really for any of the views. So let's take a look at this guy. It could be used to generate slices through our profile as well, and there are ways of doing that. But it can also generate a profile view that looks like this. And every agency is a little different on what they require, what they want to see. This particular agency, they don't show the superstructure or any of that. This is strictly their profile view looks like this, where it shows the just substructure elements and the ground and any work related to either of those. So let's take a look at that real quick. So I'm going to start up the section callout tool. Now, I cheated a little bit here. Let me pause the video for a moment. I keep it up here on my quick access ribbon tool. Very easy to add to this. You can click the little down arrow here and go add whatever tool you want. Otherwise, you would need to go to the drawing mode here, go to the annotate tab, and section callout and plan callout, and all the other callout tools are located there. All right, now that I've said that. So I placed 2 points here along the alignment and drug out here to the right side and said, okay, I want to create kind of a slice right there on my model. So I gave this a name. I just called it profile view, and this is what it ended up looking like. Now you'll notice a white outline right here. That's where the cut line occurred. Okay, everything else, so apparently the display style I had set for cut said, okay, draw that as a white 2 line. Everything else come in, so everything forward of that came in its original color, symbology, and everything else. So I'm just going to turn off the levels for all those because, again, for this particular drawing, I didn't really want any of the superstructure stuff here. I just want to be able to see my abutments here, but I also want to see the terrain model. So I'm going to go in and turn on display of the terrain model, and there we are. We have our existing ground there, and you're well on your way to finishing that out and potentially using it on a sheet. Here's another example of that profile callout tool. This time I start all the way out here and then drag across. So really nothing's going on at the cut line. Everything is forward of that. Again, because some agencies will, their profile view is as if you're standing upstream or downstream from the particular structure and taking a picture of it, or just kind of looking at it from that direction. So again, just another way of creating that particular drawing. And you can always adjust the lengths of these lines and the area you're seeing by grabbing these push pins and stretching them, and then you go back and look at the resulting model. And whereas before I was barely picking up each abutment, now we're picking up part of the roadway and maybe some wing walls and anything else that was modeled as part of that particular structure. And here's section call out on a pure model, and this will be probably the last one we do, and then we'll take any questions any of you folks have from this. So this particular one, this bridge, I don't know if anybody recognizes it. This is just, if you hit the bridge wizard up here in OpenBridge and you click OK, this is the bridge you're going to get. So I'm going to go in here and turn off everything that's at 2D. And so what I mean by that is we place decorators out there. This stuff that you see down here at elevation 0 are decorators. So in our level naming structure, anything OBM underbar D is a decorator, and then the support lines are also down there at that elevation. So I've just turned all those off for this particular view here, for this top view, and then went ahead and turned off my alignment. So basically I'm looking at just the 3D model itself in both of these views. And then from there I'll go ahead and do a save settings here, and just to show you where the section callout tool was, I went ahead and navigated to it here. But I'm going to go out here and just place a line, but this time I'm going to do it at the bearings, kind of about where the bearing line is located, and drag across. And when you do that, then again, now be careful on this. Okay, this is all depends on what drawing seed you pick as far as how this is going to look later on. And again, next month we'll talk about how to set up those drawing seeds to get them to look the way you want. But we can override a lot of that stuff when the time comes. So I'm going to tell it to go ahead and create a drawing model here. Go ahead and kick that off, and a sheet model. So it did both. And then you can look at these elements here. We can turn things on or off. If you hover over something that's referenced, right-click on it. You can say, hey, let's go move that reference right there somewhere else. And then, well, in this drawing, I probably don't want to see the superstructure. So I'm going to go into my element selection tool, select everything up here on the superstructure, right-click, hold down, say, hey, go ahead and turn off all these elements for me, accept it, turns them off, easy enough. And then from there, we might want to maybe clip this guy, create a clip of it and show just the top part of the cap here. So I'm just going to go and place a fence, go back down to my references dialog. I got the one reference here, and say, go ahead and clip this model for me. Use the active fence, accept it, and there we have the top part that substructure drawing tool did for us earlier. And then I could go in and maybe make a copy of this reference, because I also need to see the bottom half of this guy. So I'm just going to make a copy of it. Go ahead and delete the clip for that attachment. So I'll go to my second attachment here and say, you know what? Go ahead and delete that clip for me. And then let's create a new clip. So I'll go back out there, go to my place fence tool, strike a, get back out a little further, create a rectangle for that, and then clip this guy. And then of course that could easily be moved and relocated. And then maybe we want some other views out here. Maybe we want to see a plan of a cap, or a plan of a footing, or something else. So any one of those could be accomplished here. So I'm going to go back to my drawing model here, the initial drawing model that was created when I did that live slice. Go ahead and turn off superstructure once here. You could go do a save settings just so you don't have to do that anymore. But you can do a lot of your other callouts from here. So if I start up my section callout again, if I strike a line across here and pull down, it's as if I'm standing up here above the cap looking straight down on it and creating basically a plan view of the cap. Now I can tell it to go ahead and create a drawing model for this, and or a sheet model. Okay, I get to pick the scale that's associated with these and so forth. So I'm going to go ahead and let it create the sheet model. But what I'm going to do is say, hey, go ahead and put it on the same sheet that I used a moment ago, that Pier 1 elevation sheet. And oh, by the way, let's use a 1/4 inch per foot for this as well. It just plops it in the middle of my sheet. Again, hover over it. Go ahead and move it. Maybe snap to a corner of it. Maybe snap to a corner on the cap here. Hit the O button on your keyboard for the origin key in AccuDraw, and then slide it up, and now we know it all lines up nice and neat. And then we could do something similar for the footing as well. I can go back to my elevation view, strike a line across the footing here with the section callout tool, and create a plan of footing drawing. And just make sure I put it on the same sheet. Set my detail scale and my annotation scales to be the same. And pick OK. They don't have to be, but it makes sense to do that. So there's my footing view. Again, that's something that could be moved and placed relative to everything else on the drawing. And we could continue on. We could do a section of the column, a section of the cap. We could do a right elevation view, on and on. There's really no kind of limits to what we can't do with it. So here's let's say a right section view. So by slicing down through there and pulling to the right, that's going to be my Pier 1 kind of a right elevation view or right section, however you want to think of it. Again, put it on the same sheet, pick the scales. Now again, all of this is going into the same DGN file that has my 3D model. Didn't have to, but I didn't change it, so that's just simply where it ends up. So again, we can move this guy up here, maybe line it up with the cap that we already have out there. So again, really quickly, we've generated some live drawings from our model. We have both, again, drawing models and sheet models here. Again, any annotation you do for any of these, let's say you're doing dimensioning on any of these, you're going to want to do those in the drawing model, and they just show up here automatically because it's referenced in here. But any other notes or anything else you might want to apply to this particular model. So with that, I'm going to kind of stop right here, see if anyone has any questions. And let me open up one other thing here. I've got a couple of different windows open. I was working with working through there's an agency that I'm doing some training for here shortly, and they've created their own little training guide on how to go about creating a typical drawing that might be in their plans. This might be the cover sheet on their bridge plans, where they have their plan of the bridge in one location. You got a profile in another. They show isometric views now, and those are things that somebody's got to be a lot more talented than I to do something like that. But they are they've been doing those basically by drawing them by hand up until now. But they've been showing isometrics of some of their structures in that. But this was just created just by going in, reference the bridge to an empty model, and I just turned it to an isometric view and did a save view and said, okay, let's go ahead and save this view right here. And then I just attach that save view to this particular sheet model here. Same with this, use the section call out to create this guy. Did this one with a section call out, could have been done with the elevation call out as well. And this in the plan here, that's just a top view. But in their case, they had me use the, in their instructions, they used the place name boundary tool because they already had it set up for the roadway folks. And you can just create a rectangle with 2 points and say, okay, I want to do a name boundary. I want to do basically a plan call out for this particular structure, and you give it a couple of data points and place those out there. So a lot of really neat tools that they've done, and they've even come up with like a really neat little notes tool here as well using our tables tool. And I haven't even made it all the way through the training guide yet. I happened to be going through this yesterday, and I thought it was kind of apropos for what we were doing here. One of the questions I had is, why aren't the deck and barrier being displayed in the cuts? I'm assuming what you're referring to there is when we did the cut. Let me go to a different file here real quick. When I did the cut, when you use the create drawing tool here, it's smart enough to not show those things. But again, when you use the place section call out tool, it cuts through whatever levels are on at that time. So depending on what you actually cut through will determine whether those elements show up, let's say in this elevation view right here. So it looks like I do have forward view turned on, but if I go in here to this reference, I have the superstructure portion here turned off, and there may or may not be other levels turned off here as well. Yeah, so we're picking up the beams in the forward view. I think the deck and that might be here as well, but and maybe they're not. Oh, you know what? That's a depth thing. I pulled this all the way down such that we didn't see those. But if I drag that back up, then we can see the deck and the barriers as well. So part of it's controlled by where exactly I do this. I place this little push pin is going to limit exactly what we see within the model there, if that makes sense. Any other questions? If you want to unmute and ask questions, that's fine. If you'd rather type them in the chat window, that's perfectly fine as well. Okay. Maybe better off typing. Unmute. Okay. 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 So yeah, feel free to use the little raise hand icon that you see in your little participant window there, and potentially raise your hand. One other question here. Can you hatch components in the section view? I think yes. The reason I say that is in display styles here. I mean, you could always do it by hand, and I've seen some neat uses of that. But in the display styles window here, in the display rules, if we go take a peek at those display rules. So for example, well, I've got some already sitting out there, the highlight, superstructure and substructure and so forth. What you can do is, the way these display rules work, again, they're kind of an if then else kind of a way of thinking about things. So for example here, I just have this thing that says, okay, if you see any elements on a level called bridge superstructure, do a level override or a color symbology override and make it look, in this case, this kind of magenta color. And then if it's not on that level, then do this, and which was basically, okay, make it a certain color and screen it out or make it kind of transparent looking. But in these actions that we have out here, one of the things you can do is you can tell it to hatch an area. I've not tried that specifically, but I'm feel pretty comfortable in thinking that's what's going to happen. If that's the action that you choose here. For the most part, you're probably going to use symbology overrides, but you can also hide elements. You can screen them. You can assign them priorities so that some things end up on the top of or above other elements when it generates the view there. And then you can do some display style overrides. But as far as the conditions that are out here, if you were to drill down in here and look, there's a pretty lengthy list of things you can look for. I mean, you can drill down into the individual elements and key on something there, whether it's a color, a style, a weight, a level name, or something else. Is it a concrete girder? Is it this? Is it that? Something specific about a view. But like I said, model and reference as well. So you could drill into your references and say, okay, if it's in a reference, do this. If it's not in a reference, do something else. Or if the attachment has a certain logical name or path or something else, hide it, screen it, highlight it, make it green, whatever. There's really no kind of I'm limited anyway by only the things I can think of and potential ways of using this. But like I said, this morning I was having a talk with a really smart guy on all this stuff, and he'd kind of figured out the display style stuff pretty good and was getting things to look good this way, but then his concern was, well, how, if I start adding text and other things and they look different, how am I going to control that? And then that's when we started talking about display rules and potentially using those to give you even more control over how things look in a given view. So hopefully that helps. Does the BIM or standalone workflow make a difference in the time it takes to model a bridge? Does a BIM workflow make the program run slower? No. So what the question is, let me go back to OpenBridge Modeler here. I may have it open multiple times. Let's see. We'll use this guy here. So in OpenBridge Designer, you have two options here. You have a BIM workflow and a standalone workflow. These primarily affect the interaction with the analytical tools. All right. So what do I mean by that? In the BIM workflow, if you model a bridge in the BIM workflow, once you get that bridge modeled, then you can go to the Utilities tab up here and you can say, okay, go and send that to either LEAP Concrete, LEAP Steel, or RM Bridge. If you need to make changes geometrically to the structure, you always have to come back to OpenBridge Modeler to make those changes. Once you get into either LEAP Concrete, Steel, or RM Bridge, geometrically, a lot of those tools are disabled or view only. You can kind of look at the stuff, look at the information, but you can't change any of it from the analytical products. Whereas, let me go back to this. In the standalone workflow, if I send my bridge to LEAP Concrete, Steel, or RM, I can still make quite a few changes. I can't make all changes, but I can still make a lot of changes geometrically to the bridge in the analytics software. So I could change, let's say, the girder spacing. I could add girders. I could take girders away. I could go to a completely different girder. If I want to go from a 54-inch girder to a 63-inch girder, I can do that in the LEAP, like LEAP Concrete. Or if I need to change the thickness of a flange or a web or something on a steel girder bridge, I can do that while I'm sitting in the analytical product and then rerun my analysis. In the BIM workflow, again, all your changes are going to be in OpenBridge Modeler here, and then you would update the LEAP model with any geometric changes you make. Whereas in standalone, those changes that are made in the analytic tools can be sent back to here, and that's why we have the update tool. So that way we can keep this 3D physical model and your analytical model synced up with changes you make, like I said, to girders and girder spacings, changes you make to the dimensions on your caps, your columns, your footing, your pile layout. Other things we can bring back, and we're starting to delve into bringing analytical information back now. So for several versions, we've been able to bring back the camber information from LEAP Concrete. So if you've completed your beam design in there and you have your and it calculates camber on each of the beams, in our reporting tool here, for example, when you go to compute camber, and I don't have a bridge in this particular file, so I can't do it, but there's a toggle at the top of that dialog that says, go ahead and read the camber from the LEAP software. Okay, so that's where that comes from today. And the other primary thing we can do is in the LEAP products, and the two LEAP ones specifically, if you do your footing design in LEAP Concrete or Steel, all that reinforcement that's part of that design process, that can also be sent from LEAP to OpenBridge and modeled as Pro Concrete rebar. And it would have all that reinforced, the same sizes, the same spacing, same everything that you had in your analytical LEAP model would be here in your OpenBridge model as well. One other question here. Let me switch models here. There's a question about how do we get quantities. So let me go back to this simple model here. So there is a quantities report right here. And so anything you have modeled, whether it's the deck, the beams, piers, abutments, barriers, whatever, you just open this up, hit submit, and it will give you quantities for all of those elements. If you assign materials, those materials can have unit prices associated with them. The particular workspace I'm in right now, those are all zeroed out. So we're not really getting any cost numbers here, but we are getting quantities for everything. For precast beams, we do lineal feet. For steel girders, we give you the weight of each of the plates. Otherwise, everything's concrete, and we pretty much give you cubic yards. Other than pile, we do give you lineal feet on those, and then we'll give you each quantities on your bearing pads and lineal feet of barrier. But essentially everything you model out there, any of that you can assign a material. Why do we do the material? Well, hopefully you want to send it to analytics, so we want to send all that analytical information over about the concrete and the steel elements. But again, they also have a unit price potentially tied to those as well. So again, that's all in the material library here that we see. So here's our material names, unit weight, concrete strengths, elasticity, so on and so forth. So all your analytical properties get sent to delete products. But then there's a unit price option here as well. Any other questions? I know we're pretty much right at our time limit here. And I probably actually need to hop off to another call myself. But I want to thank everybody for joining us today. Let me know if you have any questions. I will take this recording and get it posted up there within the next few days as well. So everybody have a great rest of your day, and have a great long weekend too. Thanks for joining.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.